So in this video I'm going to give a couple of propositions related to units. So my very first proposition will be if we are in R, where R is a domain and we have A, B in R, okay, A, B and U in the domain. So if A divides B and B divides A, okay, this is the same if A divides B and B as saying that there is an unit U in the ring such that B is equal to UA. Okay, do not forget, of course, that A, B and U is a unit in the domain, and A and B are elements in the domain. Okay, this is a very useful proposition too. I call your attention to the fact that I forced R to be an integral domain. Okay, I did not say commutative ring because this is not true. Let me write it. Not true in general for commutative rings. Okay, it's very easy to get examples where this is not true. So we do need in the hypothesis that R is a domain. So another proposition is if A is an integer, okay, and if A is an integer, then we can say that A is a unit in Zm if and only if A and M are relatively prime. This is also very easy to prove. Just pick any Zm, you see, for instance, pick Z4. Okay, now check all the elements that are 0 and 4, 1 and 4, 2 and 4, 3 and 4. Check which ones are relatively prime. Check, for instance, here that 2 and 4 are not relatively prime because the greatest common divisor is 2, right? Or the least common, yes, it is 2, right? So 2 is not a, oh, this looks like a, I'm sorry, 2 and 4, okay? So since 2 and 4 are not relatively prime, 2 is not a unit, and that is true. Why? Because 2 times 2 is 0 in Z4. Okay, don't forget you're in Z4. Okay, so 2, this one is not a unit because it is not relatively prime to 4. Okay, so check all the other elements that are relatively prime with 4, and all those elements will be the unit in the ring. So if we have R a commutative ring, okay, the group of units, I'm not saying the set, I'm saying the group of units, units of R, of course, units, when you say unit, you always have to say in which ring, is UR. Okay, and this is the usual notation. So all we have here is all units of R. Very easy to check that this is a multiplicative group. So if an element, a unit in a ring will have only one inverse in the ring, for each element in a group has a unique inverse. Okay?